Page 303, chapter 5.2. Should be on page 303. Okay. We're going to talk about a few things in this section. All right. First, we're going to talk about what is a perpendicular bisector. All right. A perpendicular bisector. Well, we should know these two words already. We should know what perpendicular means, and we should know what a bisector is. Okay? We know that perpendicular forms a right angle, and we know that a bisector cuts something in half. Right? If we have a segment bisector, it cuts a segment into two congruent segments. Right? So we're going to put those two things together to make a perpendicular bisector. Okay? So if we had something like this, let's say we've got a segment. We've got segment AB. In order to draw a perpendicular bisector, the first thing that we're going to have to do is we're going to have to find the midpoint. Okay? Because the midpoint always bisects a segment. Okay? Right, so let's say our midpoint, we'll call it M for midpoint. It's going to be somewhere right about there, which tells us AM and BM are congruent. Okay? So the first thing we got to do is find the midpoint. We found the midpoint. That's the bisector part. Now we need to make sure that it is perpendicular. So what we are going to do is we're going to draw a line that is perpendicular to AB and goes through point M. Right? Now you need to pay attention because this can get confusing to some. You're going to need a ruler of some sort. Right? I've got one right here. And most every ruler that you have, that you buy now, is transparent. You can see through it. Right? And if you look at all the marks, okay, look at all the marks on your ruler. If, for instance, this mark right here with the number 1, if I was to look at the angle of that mark compared to the edge of my ruler, okay, so this mark right here and the edge of my ruler, they would form a right angle, okay, which means they're perpendicular. Every mark on this ruler is perpendicular to the edge. Okay? So we're going to use that in order to draw a perpendicular line. What I'm going to do is I'm going to pick a line on my ruler. I'll use this one next to the 4. Right? And I'm going to line it up. I'm going to put it on top of the line that I'm looking at. Okay? And I'm going to scoot it over until I get to my midpoint. Right? And now that I'm at my midpoint, okay, I can draw this line on the edge of my ruler, and I know that this is perpendicular because the angle from my line on the 4 ruler, okay, on my ruler on the 4, and the edge of my ruler forms a 90-degree angle. All right? It's kind of confusing maybe to some. You just have to practice it. Match up your line to whatever line you want to be perpendicular to, and then we draw along the edge. Okay? Anyways, this is, right here would be our perpendicular bisector that's going vertical. Alright? It goes through the midpoint and it's perpendicular to our segment. Alright? Now we have a couple of theorems that we're going to talk about. Theorem 5.2 is called the perpendicular bisector theorem. Right? The perpendicular bisector theorem says if you have a point, okay, if you have a point on the perpendicular bisector, then it is equidistant to the endpoints. Okay. So if you have a point on the perpendicular bisector, then it is equidistant to the endpoints. Let's talk about what that really means. Right? Right. I can pick a point anywhere on my perpendicular bisector. It can be all the way up here anywhere. It can be anywhere down here. I'm going to put mine, let's say, right there. I'm going to call it P for point. Okay. According to Theorem 5.2, if I have this point P, okay, that is on the perpendicular bisector, then I know that the distance from P to B and the distance from P to A, those two distances are the same. They are equidistant. Okay? They have to be. They're equidistant. Because any point that is on this line is going to be the same distance from point A as it is from point B. Okay? That's Theorem 5.2. So let's say that AP was 4. Well, then B would be, or PB would be 4. Let's say that AP was 4x plus 10 and PB was 44. All right? This would be a good example of something you might have on your homework. Right? If we wanted to solve for x, because we know that AP and BP are congruent, we would have to say 4x plus 10 equals 44. Right? And there's our two-step problem. First thing we're going to do is subtract 10 from both sides. So we get 4x equals 34. Right? Then we're going to divide by 4. Right. Now, what is 34 divided by 4? Well, 4 goes into 34 8 times. Okay? Here, let's do it over here. Goes in there 8 times. 8 times 4 is 32. Which gives us 2 left over. So we say 8 and 2 over 4. Reduce that and we would get 8.5 or 8.5. So in this case, x would be 8.5 or 8.5. Okay? Perpendicular bisector theorem. Okay? If we were going to write the converse, let's remember an if-then statement, when we want to write the converse, remember we flip the hypothesis and the conclusion. We would flip it. Okay? That's going to be our next theorem, Theorem 5.3. Is the converse of the perpendicular bisector theorem. Right. The converse, okay, the converse, if we wanted to flip this, we would say if you have a point that is equidistant to the endpoints, then that point is on the perpendicular bisector. If you have a point that is equidistant to the endpoints, then that point is on the perpendicular bisector, right? So it's the same thing as this, we're just kind of going backwards. Right? So let's say that we have segment AB again. Right? And out here we have point P. Okay? And when I measure the distance from point P to point B and from point A to point P, I find out that these distances are the same. Okay? When I measure from A to P and from B to P, I find out they're the same distance. Okay? So with that being said, if I look at our theorem, it says if you have a point that is equidistant to the endpoints, in which this case it is, then what do I know about that point? It says that point is on the perpendicular bisector. It has to be. Okay? That point has to be on the perpendicular bisector. Alright? So here we said, up here we said, if you have a perpendicular bisector, then every point on that perpendicular bisector is equidistant to the endpoints. Alright? Down here, we said if you have a point that is equidistant to the endpoints, then it has to be on the perpendicular bisector. Alright? It's just the converse. It's turning it around. Alright? Okay. So, what we are going to do with perpendicular bisectors, alright, we are going to use them, well, you'll see how we're going to use them. What I want you to do is I want you to draw a triangle that looks like this. Something like that. Try to make the line straighter than mine. Alright? We've got a triangle. This would be an acute triangle. What I want you to do is, or what we're going to do together, is we are going to draw the perpendicular bisectors. Alright? Now, in order to draw the perpendicular bisectors, drawing, here are going to be our directions. Right? The first thing I'm going to do in order to draw a perpendicular bisector, I'm going to have to find the midpoint. Okay? I need to find a midpoint of each side. Okay? So I can take a ruler and I can measure and find, whoops, okay. Measure them and find the midpoints. All right. That's the first thing that you're going to have to do. After that, the second thing is we're going to have to draw the perpendicular lines through those points. Right? That's where we're going to use our ruler again. Let's do AC first. Okay. Remember, we're going to pick a line on our ruler. Okay, I'm going to pick the number 4 line again. And I'm going to line it up with that side. And I'm going to slide it till I get to the point. All right? When I get to that point, I'm going to draw a line, because that is my perpendicular bisector. Alright? So everybody's triangle should look like this so far. Okay. Now let's do BC. I'm going to line up. Now my line isn't real good. Okay. Well, let me fix my line here. I'm going to line up my line and wait till we get to the midpoint, and there we go. Okay? So now we should have these two. And let's do this last one. Right. Okay. Now mine is obviously not perfect. If you did yours better than mine, you would notice that the three perpendicular bisectors intersect at one point. Okay, it should look something more like that. All right? So, they're going to intersect at one point, and this point is called, it is a point of concurrency. Okay? It is a point of concurrency, and it has a specific name, right? Its specific name is called the Circumcenter. All right? So what we're going to be doing for this chapter, okay, you can do this on another piece of paper, on the notes that you have, I don't care. We are going to be making a list, right? We're going to be making a list of points of concurrency. There are going to be 4 different points of concurrency. All right, so this is the title of your list, points of concurrency. All right, now what that means is, let's think about the word concur. If I was to ask you, do you concur, that means, do you agree? Okay? We call this a point of concurrency because that's where the lines agree with each other. That's where they intersect. Okay? So, our first point of concurrency, we were talking about perpendicular bisectors. Okay? And perpendicular bisectors, they intersect at a point called the circumcenter. Alright? Now, if I was to take a compass like this, right, and I put the needle there, and I put my pencil, see, I'll try to make it where you can see it, on the end, or on the vertex, one of my vertices, okay, of the triangle. And I draw a circle. Now that wasn't perfect by any means, but if I was to do this just perfectly, I would see that that circle goes through each of my vertices. Now it was a little off up here, but it should go all the way through each of my